So I've owned the UMC 500 for exactly 1 year. And in this Pierson Workholding Q&A, I'm gonna give you 3 pros, 3 cons, something in between, and answer the question, am I gonna keep it or am I gonna get rid of it? So as I mentioned in the intro, I've owned this UMC 500 for exactly a year, almost to the day. We've ran it, we've probably got about 1,500 hours on it. So it's not quite the 2,000 hours of a full year, but it's enough to know all the pros and cons. So in this video, let's cover some of those. Now, the number one general question I get emailed to me is, hey Jay, love the series. Wondering, what are your thoughts on it? So let's talk about it. Let me talk about the pros. First of all, I absolutely love having a 5-axis machine. In some of our other videos, you've seen that we used our Pro Pallet System base, and we created a custom pallet to hold our rotovise. It's Pierson from top to bottom. And so that's allowed us to hit not just the 4 sides, or rather 4 parts, 3 faces each. With some of the work we had done on our 4th axis machines, like on our VF2s, all of them are equipped with 4th axis rotary drives. So we've been able to take that and just do, like in Fusion, it's called a tool orientation, where we just immediately press cycle start, it rotates the B axis over, and then it's just rotating and it's running like a 4th axis. In the last video, you saw that we put some pockets on the face of one of our components where we just tilt it back up, where B and C0, and it puts those pockets. It's that type of stuff, that setup reduction, that we absolutely love around here. I think the sexy part about owning a 5-axis machine is the simultaneous 5-axis movements. There's no doubt about that. Talking with most other business owners, most knowledgeable, reputable people in the industry, and even our salespeople with Haas, they've said that one of the biggest selling points is setup reduction. You have one part, and instead of doing like the typical op1 advice, flip it op2, maybe hit op3 or 4 in different setups, it's basically 2 operations. You have just the top, you hit all the sides, and then what we do is we do one piece flow. That's a lean principle. So any of the adjacent machines will take that, put it into a vise, and so we have 4 parts coming off this. We have a double vise, 4 parts in that, deck off the part that we held, heard a term recently, we'll put it right here that I absolutely loved, and where you just cut that piece off and then you have finished parts. So that's the beauty of it. You don't get to op4 and go, oh man, I can't hold this, or I screwed up way back in op1. You are so much closer to complete with a 5-axis machine. Now, the next thing I've really grown to appreciate is the footprint of the machine. Now, the UMC 500 is the smallest 5-axis machine that Haas makes. I know that there's other brands that have smaller footprints, but I've seen some huge 5-axis machines that are maybe not as wide, but are far deeper and have, arguably more travel. But really, for me, the UMC 500 was just the right size. We don't do a lot of large parts. Everything is, I would say everything we make around here, or at least that we would put on the machine, is about a 4-inch cube workpiece size. So this was just the right machine from the beginning. I had known about the UMC 750, but when the UMC 500 came out, in my podcast with Mark Terryberry, I actually said, maybe tongue-in-cheek, that the UMC 500 is gonna be the new VF2. VF2 being Haas's best-selling machine, VF2's SS to be specific. It's just the right price, it's the right size, compact, easy to use. With the Haas control, we were familiar with it on day one. All these factors just played into just kind of me reconfirming my love for a machine of this size. Now, the next thing I've really grown to love is the through spindle coolant, both air and high pressure coolant. This is the first machine that I got it. Now, these are expensive upgrades, but when you have, my reasoning is when you have the B-axis rotated, maybe the standard coolant nozzles may not be able to reach some of the areas that the tool is cutting. And for that reason, I thought, hey, let's just invest the extra money and go with through spindle coolant, through spindle tool air blast, and just get into those nooks and crannies that might be blocked out. I'm not sure I would get it on the 3-axis machine. I think the standard coolant nozzles with P-Cool, at least what we're doing, has been more than sufficient. We've actually upgraded a lot of our drills. Shout out to SGS Kyocera. They have some drills that perform at almost the same feeds and speeds as traditional coolant through drills, just straight plunge, high feed rate. And so we don't have really a need for through spindle coolant. And I know, I'm not gonna argue against anyone that has it. If it were a free upgrade, I would definitely take it. But that's one of the things I've really grown to love, especially with a machine like this, where you're not sure if you can get coolant to those specific cutting areas. Okay, next, let's talk about some things that I'm kind of indifferent about. So the first video we released about this was the new Haas touchscreen. Now, I don't know where Haas is with equipping machines with touchscreens. I found that we don't actually use it. One time I came up to the machine and I thought, oh yeah, I forgot that it has touchscreen capabilities. Let me start touching around, see if I could get used to it, and it wasn't working. Well, one of my guys had turned it off, and the reason is when you have two machinists standing there and you're talking, inevitably you're going to point to different parts of the screen and go, oh yeah, when the code goes here, and you end up highlighting stuff, scrolling stuff, activating menus that you didn't intend to. So I think it's probably on half the time. It's really operator preference. But for us, it didn't really fit into our standardization because none of our other machines have touchscreens. I think if it had been around for 10 years, I think we would really like it, and that would be part of our natural workflow or our touch flow. But for now, I'm kind of indifferent to it. I'm glad it has it. I don't think if it were a paid upgrade that I would pay $500,000, $1,500. I wouldn't do that. It's just not necessary. It's definitely faster to navigate, which I really like. Go figure, mouse and pointer, that's how we all navigate on computer screens. So I like that aspect of it, but for the most part, it doesn't really speed us up, doesn't really slow us down, so kind of indifferent. Now, the next thing I'm kind of indifferent about is the remote jog handle. I kind of laughed when I saw that it was just a standard thing, or I don't know if it's standard these days, but it just came with the machine, and I picked it up and I thought, why are we going to use a remote jog handle on this small machine? Now, fair enough, one of my guys said, no, I actually do use it when I'm around the side of the machine because I can really jog in and see if things are going to clear. It's just nicer to have. It's a compact machine, but it's not small enough like on some of my mini mills where you can really get in there and dial things in. You can't reach around the corner. That's an obvious fact right there. So for me, I'm not sure what the price is, maybe $1,000, $1,200, $1,500. I don't think I would add it on. The nice thing is we can actually detach it and put it maybe on our VF4 SS. The guy that runs that, he's about 6'3". He has no problem. I'm 5'11". He's 6'3". He has no problem, you know, and so he wouldn't use it. So we've just decided to just keep it on the machine. But again, kind of indifferent to it. Okay, this next point, I can't say I'm indifferent to it, but I made a conscious decision to only go with 30 tools rather than 50 for another, I think about $1,600. It comes out to about $800 per pocket. We haven't missed those 20 tools that we don't have. In fact, we have done a lot of good study of the types of parts we're gonna make in the machine, and we standardize all 30 plus 1 tools in the machine. So for the most part, we cut 2 materials. We cut aluminum, 6061, and 416 stainless in this. So, you know, our first about 20, 22 tools are for, you know, most of the aluminum parts. And then we have some simple 416. We only use about, you know, maybe 5 tools, maybe 6 or 7 on that. So we pretty much have it standardized. if I was running a job shop, I would definitely spring for 50 tools if you're going to practice tool standardization. If you're making a part that requires 40 tools, I would probably revisit the number of tools that you're using. Not only is it tool changes, but it's setups, and then you're taking those tools in and out. The best way to increase production and speed up setups is to not do setups at all. And so for us, we keep the tool magazine loaded. We actually have only 2 works offsets, the center of the table and the center of the round and diamond pin on our PPS base that's pretty much left in there permanently. Those are the only 2 origins. So when we program something and all our work is palletized or on the row device, we put it in, we can confidently walk up and hit cycle start because we've proven it in our CAD CAM system. Now, let's get to some cons. One of the complaints that other UMC 500 owners have shared with me is chip evacuation. And I will say that we have experienced pooling up of coolant at the bottom of it. And that is because the belt style chip conveyor, it can get clogged, not the chip conveyor itself, but along the sides. So I can't really fault Haas for this, although if you want to, that's fine, but here's why. No system is perfect. Even our auger style chip augers, not conveyors, they're literal augers, they sometimes get clogged up because of the type of chip. Now, we've moved from, instead of a long flute, rougher, we use a long flute, but it still has a serrated teeth so that we have short, less stringy chips that don't clump up. If we have long chips in our augers, that auger will just rat's nest and it will eventually not push anything out. We need to break it up or just scoop it out with a pitchfork. Same thing here. Chips will start to accumulate. It's a really easy maintenance process. The guys know how to do it now. There's 2 slots along the trough where the belt runs. We just poke those with a few just sticks, like 1/4-inch aluminum rods, and then you'll break it up and you'll just see coolant drain out. A friend of mine has a UMC 500. He just said that he pulled out the chip conveyor just a couple feet just to clean out those remnant chips, part of regular maintenance. So yes, you could put it in the con column, but it's not like it's a deal breaker. It just requires a little bit of experience with the machine and know how to keep the thing running right. Okay, another con would be the paint. So 1,500 hours, the paint is starting to chip in the pan. Now, all of our machines, especially along the plane of Z where we do most of our cutting, you see this line of worn away paint from chips hitting the wall. This, I can't say that I can excuse Haas on this. Now, the back panels you see behind me is stainless steel, so that there's no wear there. But down in the pan, you see some chipping. I did not expect this. The only other machine that we've seen this on is some of our older, now by older I mean 2015 VF2, that runs cast iron. It runs hardened stainless, like 416, 303, and also 4140. And that's just wear and tear, that's normal. And then my dearly beloved Haas Mini Mill model year 2000, there is no paint on the bottom of the pan. That's fine, it's not rusting, keep the coolant concentration right, it shouldn't rust. But it kind of surprised me that after a year we saw paint chipping. QA, I don't know, maybe they were switching stuff up, but it's a kind of a con. I don't know, I just kind of thought that it would last a little bit longer. Okay, now the final con is a concern that I had very early on before I purchased this machine, and it applies to just the geometric design of 5-axis machines. Now, if you notice on this machine, the table doesn't move at all. Yes, it rotates in both the B and C axis, but there's no XY linear motion. All that X, Y, and Z linear motion is handled at the spindle. So the X is the base travel. It moves left to right. The Y axis rides on the X, and then the Z axis is attached to the Y. So I look at it like this. When you are machining far out, away from the back of the machine, close to the front, you have two relatively narrow, now I think they're at least maybe 24 inches apart, 18, 24 inches apart. You have two rails and you're trying to support the cutting forces, and you don't want these two rails to flex in the X direction, okay? We have experienced that. So we have experienced that when we are taking finish cuts, no, correction, even roughing cuts, more so roughing cuts, but finish cuts with the Y extended fully out with a long length of cut. When you have a long length of cut, especially on a high helix end mill, you have at least 2, 3, possibly 4 flutes engaged, because remember, it's helical. So the first tooth engages, that goes away. You have the next spiral flute engaging, and then you have the third spiral flute engaging at 3 different levels along the height of the part. So when that happens, you have 3 times the cutting force pushing that over. And it shows up not in surface finish, but dimensionally. Now, what is too much? Well, that's up to the print, but we've seen dimensional changes where it takes one finish pass cut, and we see that it pushes that out 2 thou per side, so 4 thou. Now that still falls into the typical average plus or minus 4 thou tolerance. We don't run anything with tight tolerances on this machine. If there are tight tolerances, it's gonna be a drill, it's gonna be a ream, we're gonna come back with a smaller cutter, and we're gonna interpolate something. These cuts are on the outside of a vacuum power unit, where it's cosmetic for the most part. So we would never push the machine and take these types of cuts that would compromise the quality of the part. So kind of my suspicions about this style of machine, not necessarily Haas's design, but this style where everything is stacked on another axis, there's just inherently a potential for that to happen. So the question I posed at the top, do we keep it? Do we get rid of it? We're definitely keeping it. I love this machine. I love 5-axis. I love everything that this has been producing. It's been just a tremendous workhorse. Would I buy another? The answer to that is maybe. Now, I love the lean aspect of 5-axis machines, especially this small size. This price point is fantastic in my opinion, especially if you can catch it on one of Haas's multi-annual sales. It's just, even if you didn't get it on sale, it's still a fantastic value over similar brands. Now, I will say that from a lean aspect, the setup reduction by hitting multiple faces, multiple parts like we run, that is just part of our ethos. Do we have a need for another 5-axis machine? Probably not in the next year or two. In fact, probably the next machine that we're going to just experiment with would be a horizontal. I think there's a lot of things we can do with a horizontal machine, including launching our new 5-axis palletized work holding system that we're going to put on this machine next, and someday our future horizontal. So for now, yes, I would buy another UMC. Would I recommend it? Yes, but just know that it's not gonna have the same rigidity as a time-tested and proven vertical VF series. And would I take a VF 2, 3, 4 over a UMC? It really just depends, if what's right for you. So if you're doing a lot of parts that require multiple setups, UMC is the way to go. If you're doing bread and butter stuff, might be 2, maybe even 3 operations in a vise or one of our pallets. Yeah, a VF would be fine. It really comes down to what type of parts just pass through your shop. So for me, yes, I would recommend it, but I can't say anything negative about it. It's more about the machinist and not the machine. So let's jump into CAM and I'll show you how a seasoned machinist would program around some of the quirks and nuances of any machine once they get to know it. So what I have here is a very simplified setup of the valve that we've shown in previous videos. Now I have my adaptive, which is synonymous with high-speed machining, profit milling. It's just a more modern tool path. The next one is a finish, and then I'll show you the trick on this third finishing pass. So let's go through it. Adaptive, if we just simulate this, you'll see that it does exactly what you would expect it to do. It's just going around. It's taken up to 75 thousandths width of cut. Then we come in with our finisher. Now, typical finishing passes are done in a clockwise rotation around the part. So it's gonna come in, it's gonna drop down, and it's gonna go around clockwise. Now, what we've done here is Adaptive has left about 10 thousandths of material on the part. That may be a little bit too much. Some people think it's too little, but for us, it's just right, because when we do an adaptive pass, the adaptive is a high speed, low accuracy tool path that's intentionally of that. So it can drift off the intended tool path by what we specify of about 8 thousandths. So that's why we leave 10 thousandths of material around the perimeter of the part, because if it drifts as its maximum allowable offset, which would be 8 thousandths, we still have about 2 thousandths of material left that we can take off in a finish pass. So backing up, it's moving around, and you can kind of see the difference between the blue, the previous tool path, and the green. It's cleaning up, but if you zoom way in, we're leaving about 1 thou of material there. I know Fusion kind of makes it look a little different when you zoom really close in, but we're leaving some material. Now that's only half of the formula. Once it gets all the way through the cut, you'll see it retract, and then we basically copied this same tool path over here, and we just pasted it with one change. So let's jump back in. So this one, it just went to its home position, it comes back down. Now here's where it changes. I told you a finishing pass will take a climb cut clockwise around the part. In this case, we are doing a conventional cut around the part. Now that conventional cut, the difference is a climb cut with the tool cutter spinning clockwise. When it enters the material, it is a harsh cut. It grabs material instantly. With a conventional cut or an older tool path, what's happening is the cutter, as the flutes are coming around clockwise, they're easing into the cut. So it's not thinning the chip, it's entering the chip in a thin part, and it's exiting with a decent amount of thickness. Now, when we get all the way around, that easing into it reduces the amount of chatter, because the teeth of the cutter are not having a hard impact in it, they're having an easy impact, and tool deflection isn't bouncing left, right, left, right, left, right from the jarring of the tooth entering the cut. It's an easy way around the part. And if you step back and take a look at the difference between these two tool paths, they're pretty much night and day. Now, between a conventional cut and a climb cut, the dimensions are the same, but you'll see that the chatter is pretty much made non-existent or highly reduced. So keep that in mind. So I hope that was of value to you. If you haven't yet done so, consider subscribing. We want to provide more value to you to make everyone out there a better machinist. So until next time, go innovate your production.